Hello everyone, this is the topic factor on which resistance depends, and in the previous class I have explained you the expression V is equal to IR, that is V is equal to IR. There I told you that this R is a constant, and this constant is called the resistance of a conductor, and there are many factors on which this resistance depends. And one more important point to be discussed here today is that what is the reason which give rise to this resistance in a conductor. So let's discuss in detail. In the previous video I explained you the resistance is a property of a conductor by which opposes the flow of current. Opposes the flow of current means opposes the flow of uh, electrons. In this video we will try to explore what is inside the conductor which uh, force electron to suffer a resistance. This can be understood by this diagram and easily. Let me draw it for you. So first, up to here it is clear to you that resistance is a property of conductor by which it opposes the flow of current through it. So let's try to understand what actually inside the conductor which force the electron to suffer this resistance. Definitely I have drawn here a conductor, okay, and this you can consider a battery over here. For the time being you suppose it to be a battery. I've connected it like this, okay, and current is flowing. This is a positive terminal, this one, this is negative terminal. Current is flowing in this direction. And electron flowing opposite to the current direction. This I have explained you in the previous videos. Inside a conductor there are two charges. One, obviously you know, that is electrons. These electrons really present inside a conductor from a conductor, but really it is a matter of great concern from where these electrons come. Definitely from your previous knowledge you know that electron is associated with a nucleus. Around the nucleus they revolve, and when battery supply energy to the atom, loosely held electrons in outermost orbit leave the nucleus and they freely start traveling inside the conductor. Means you can understand very easily these electrons must have come from an atom. If an electron, suppose this is a atom, and if one electron, if one electron leaves this atom become positively charged. This atom become positively charged. It means inside the conductor also here positive charges are also available. Positive charges also available here also, here also, and here also. And these positive charges travel opposite to the electrons, because positive charges will be attracted to the negative terminal of the battery, and negative charges means electron will attracted toward the positive terminal of the battery. Means I want to say that in this direction, in this direction, positive charges moving, in this direction negative charges moving, and these positive charges will obstruct the path of the electrons. Means electron will collide with the positive charges because both are moving in opposite direction, and in this way electrons suffer resistance because positive charges disturbing the electrons, and this is what we call the resistance. Because this is the reason resistance comes into picture inside the conductor. Okay, I hope that this you must have got the point why a conductor having a resistance due to the positive charges or ion, you can say. So resistance is a property by which a conductor opposes the flow of current, and what exactly happening inside the conductor, that also I have with the help of this diagram I have explained you. Let's proceed. The next heading is this: factor on which resistance depends. So there are four factors. One by one let's understand, try to understand. So here first factor is the length of conductor. The length of conductor. Here what is written: resistance directly proportional to length of a conductor. Means if there are three conductors, and then definitely third one will have the greatest resistance, because the resistance directly proportional to length. Okay, so this is a factor which has been verified by experiment. It is experimental fact and result. Okay, so this will third one will have the greatest resistance, means than 2 and 1. So resistance directly proportional to length of a conductor. More the length, more will be the resistance of the conductor. Okay, so a conductor not only having the length, it also has thickness. Okay, means cross section area. This I have explained you in the previous video. What is cross section area? Okay, means thickness. So thickness of a conductor also matter a lot, that we call the area of cross section. Here resistance directly not proportional to cross section area. Here it is inversely proportional, means resistance inversely proportional to cross section area. Means more the resistance, means smaller the cross section area. Means thin wire. Wire having the high resistance and thick wire having the lower resistance. Okay, this is also experimental fact. So what we can say that we have got the two relations. And what are the two relations? The resistance directly proportional to length, resistance inversely proportional to cross section area. If we combine these two relation, what we will get? We will get this relation. This relation we will get means resistance R is equal to L by A. This is not this is proportionality sign. This is not equal to not. This is a proportionality sign. Okay, so here you keep in your mind that if we combined both relations, we get here resistance directly proportional to length upon area. And as you know, when this proportionality sign is removed, what happens at that time? A constant come into picture, and this constant we call rho. This constant is called the rho, RHO, rho. This is pronounced as rho, and it is called the resistivity of the conductor. Okay, it is called the resistivity of the conductor. Then next question is, what is resistivity? Then let's explain. This is important formula, you keep in your mind. Okay, let's try to understand what is this rho, what is this resistivity. Resistance R is equal to rho L by A. If I take length 1 meter and cross section area 1 meter square, R is equal to numerically equal, both will be equal. Okay, the value of L is also 1, a value of A is also 1, 1 cancel, means nothing, means rho equal to resistance. It means when a conductor having the length 1 meter and its cross section area is 1 meter square, at that time the resistance of the conductor is called the resistivity. That's it. Means resistivity also is a resistance of the conductor. And the only difference between the resistance and resistivity is that resistance depends upon length and cross section area, but resistivity does not depends length and cross section area. This keep in your mind. Okay, but one thing is common between the resistance and resistivity, that I will let you know. Just keep on watching it. So we are on the factor number 3. On factor number 3, material of the conductor. Material of the conductor means which type of material a conductor is made up of, that also matters a lot in the case of resistance. Okay, means there is a copper wire having different atom, silver wire, and there are alloys, they are made up of making more than one metals, and alloys having the high resistance. Okay, so nature of the material also decides resistance of a conductor. Here what I have explained you, that is written here rho. So resistivity of a material is the resistance of wire made up of that material of a unit length and unit cross section area, that I have explained you. Temperature is also one of the most important factor. uh, Rise in temperature of a conductor give rise to the increase in the resistance of the conductor. Means resistance of a conductor directly proportional to temperature, T for temperature. If temperature increases, resistance also will increase. Okay, so here let's try to understand this rho or r resistance and this resistivity. Okay, and there is a difference, you try to understand it. Resistance depends upon length, cross section area, nature of material, M for material, and temperature. Okay, but resistivity depends upon nature of material and temperature only. Okay, so this is the difference, you keep in your mind. This is what is most important. In this video this much only. Wait for the next video. Thank you.